Okay, good afternoon, everyone. Welcome to physics class. I hope you are in a good mood for learning new things this afternoon. So perhaps I have an idea that you already have encountered this topic this afternoon, but we will just build more of the concept of it. So our objective this afternoon, we have to state Newton's law of motion and identify the forces acting on a body in different situations. Another objective this afternoon is to describe how the motion of a body is affected by the forces acting on it and solve problems using the equation, which is F is equal to ma. So now let's start with this question or answering this or trying to define the word dynamics. What is dynamics? How will you define dynamics, class? Any idea? So when we say dynamics, as you can see there, it is a branch of physical science and subdivision of mechanics that is concerned with the motion of material objects in relation to the physical factors that affect them. What are these factors? We have here the force, mass, momentum, and energy. So in short, dynamics class, dynamics will explain or it explains how an object moves in terms of the forces which change its motion. So that's how we define dynamics. It concerned more on how to explain the object moves in terms of, again, forces which change its motion. So that's how we define dynamics. So we have to be familiar of the force, mass, momentum, energy as physical factors of our motion. That is what we are more or much concerned of in dynamics. So now let's proceed next. So in dynamics, we really have to define the word force. So this is a main factor in here. So what is force, class? So in our basic concept about force, we say force is a push or a pull. So just a review. And a force can change the size, shape, and motion of a body. Another thing also in force that we need to remember, the unit of force is Newton, or it is symbolized or represented by capital N. And another thing also, force can be measured with a spring balance. So as you can see there, so an example or illustration of a spring balance. And examples for force, we have the friction, the weight, air resistance, electrostatic force, and magnetic forces. So you are familiar with this. So do not forget that force is a push or a pull. And it's measured in Newton. So next, so what is balance forces? So balance forces, if the forces acts on the body, then the body is balanced. What I mean is if the forces acts on the body is balanced, then it stays rather at rest. Again, if the forces acts on the body is balanced, it stays at rest. So as you can see, and in the illustration there, you have your arm pulling up and your weight of suitcase rather is pulling down. So the two forces balance, so the suitcase stays still. So as what I said, it stays rather at rest when forces acts on a body is balance. So another example, weight pulling down and then the chair is pushing up. So there is, or the object stays at rest, or two forces balance. So as you can see. Another example is a tug of war game. So are you familiar with that? And another example is in the next illustration, which is air pushing up balance, string pulling down, and the weight pulling down balance, ground pushing up. So that is the last example for the balance forces. So now, or it moves with constant speed. So when it moves with constant speed, as you can see, there's a force of friction drag there, and also force of gravity, which is your weight, and the steady speed. So the force is balanced. So the parachutist falls at a steady speed. So even that happens when it moves with constant speed. So another example, the aeroplane, and also this one, the two forces balance. So the bicycle goes at a steady speed. And also this one, the forces balance moving with constant speed. So it moves, or the force moves with constant speed. So next, so if the forces acts on the body is balanced, then the resultant force is zero. So I want you to remember this one. So if you encounter this one, please don't forget this. So again, I'll repeat, if the forces acts on the body is balanced, then the resultant force is zero. So you can see it in there. So example, let's have an example. 6,000 newtons. So 6,000 newtons in your forward force, and then another is the backward force, which is also 6,000 newton. So resultant force now will give us 6,000 minus 6,000 newtons, which is 0 newton. So now remember getting the resultant force. It's like the combining the vectors that we had, opposite directions. We have to subtract, and same direction, we have to combine them or add them. So as you can see, there is a backward and forward forces. So we have the resultant force becomes 0. That means that the forces acts on the body is balanced. Therefore, the resultant force is 0. So I am showing now the example how the forces acts on the body is balanced, then the resultant force is 0. So another example number 2, the tug of war. So we have we have two opposite forces that we have. We have 500 newtons, the forces going to the left and the forces going to the right, which is also 500 newtons. So it is balanced. Therefore, as expected, when we try to get its resultant force, since it's balanced, then what do you expect? The resultant force becomes 0 newton. So 500 minus 500 is equal to 0 newton. I hope you can follow. A very simple illustration. Okay. For a while, I have to erase this one. Okay. So now let's talk about Newton's first law of motion. So what could you still remember about Newton's first law of motion? I know you already completed the IGCS ebook of physics. So what is Newton's first law of motion? So Newton's first law of motion, class, it states that if the forces acting on a body is balanced, then if it is at rest, it will continue to stay at rest. Another, if it is moving, it will keep on moving at a constant speed in a straight line. So that is what the Newton's first law of motion states. So that means that an object will remain at rest or in a state of uniform motion unless it is acted on by a resultant force. Remember that. And this resultant force can be described in a simple equation that we use to calculate acceleration. Remember the formula? F is equal to ma. We will tackle F is equal to ma later in the second law of motion. So if no resultant force acts on an object, so F now becomes 0. So that means that it will not accelerate. So that is how the explanation of the Newton's first law of motion. If the forces acting on a body is balanced, then if it is at rest, then it will continue to stay at rest. If it is moving, it will keep on moving at a constant speed in a straight line. So that is the Newton's first law of motion. So now we can now define the unbalanced forces in here. So what is unbalanced force? A while ago, that was balanced forces. So now let's proceed to unbalanced forces. What is unbalanced forces? So when we say unbalanced forces, or the cause, or its causes, unbalanced forces causes a stationary body to move. So again, unbalanced forces causes a stationary body to move. So as you can see in the illustration, so unbalanced forces in there causes the person to, or a stationary body to move. So another example, the tug of war. And also this one, okay? That is, or the picture shows an example that unbalanced forces causes a stationary body to move, or a moving body to change its velocity. So aside from unbalanced forces causes a stationary body to move, it, or a moving body to change its velocity. So what will happen? So example of that, we have here forces for the unbalanced or changing velocity. It shows accelerating. That means that the forward force, as you can see, the big arrow. So this one, the forward force there. So it shows unbalanced, right? Because the forward force is greater than the backward force. So that means if forward force is greater than the backward force, then forces are unbalanced. And it means that there is a changing of velocity, or the car is accelerating. So that is the meaning of that illustration. It shows unbalanced forces. Another thing also, what have you observed in the illustration, second illustration? The second illustration shows what? It still, yeah, it still shows unbalanced forces, but in this case, the backward force, or for, yeah, the backward force is greater than the forward force. So, as you can see, the backward force is greater than the forward force. Again, this shows still forces unbalanced, and there is still changing in velocity, but this time it is not anymore accelerating, but it is decelerating. Why? Because the backward force is greater than the forward force, and it shows deceleration or decelerating. Okay? So that is the cause of unbalanced forces. So next slide. So if the forces acts on a body is unbalanced, what will happen? Then there will be a resultant force, of course. Again, if the forces acts on the body is unbalanced, then there will be a resultant force. So let's have an example. 500 Newton for the forward force and 1,500 Newton going to the right, which is the backward force. So what will happen in here? So to solve, of course, the resultant force is now equal to 5,000 rather, minus 1,500, and that gives us 3,500 Newton. So this one, okay? So what does it mean? The forces acts on a car is unbalanced. It's very obvious on the illustration. So it accelerates because forward force is greater than the backward force, as I mentioned a while ago. So let's have another example. Example 2, this one. What have you noticed? So you can notice that the arrows, of course, they are not equal. So it's still unbalanced. And the direction is now in opposite, like 2,000 Newton for the forward force. And for the backward force is 6,000 Newton. So that shows that the backward force is greater than the forward force. So with that case, or in that case, or rather with that, we can have our resultant force is equal to 6,000 minus 2,000, and that gives us 4,000 Newton. Can you follow? I guess you can follow because this is just very easy for you. I know that. Okay, so now we can have, so that means that the forces act on the car is unbalanced. Very obvious again in the illustration. So it decelerates because the backward force is greater than the forward force. That's why we have a resultant force of 4,000 newtons. So can you follow? Yes, you do. Okay. So now, let's talk about the Newton's second law of motion. So what is in Newton's second law of motion? Can you still remember? Okay, it states that, or it states rather that the acceleration of the body is directly proportional to the direction of the force applied and inversely proportional to the mass of the body. So I want to highlight this one, that the acceleration of the body is directly proportional where? To the direction of the force applied. And aside from that, it is inversely proportional, the acceleration to the mass of the body. So take down note of that. Acceleration, according in the second law of motion, or Newton's second law of motion rather, acceleration is directly proportional to the force and inversely proportional to the mass. So to continue, the greater the mass, or that means that the greater the mass of an object, the smaller acceleration it is given by a particular force. Again, the greater the mass of an object, the smaller acceleration it gives by a particular force. Okay, so another thing also, the mass and acceleration, I mean, the force, mass, and acceleration can be combined in the following equation, or it can be described in this equation. Force is equal to mass times acceleration. As I mentioned a while ago, this equation can be written as F is equal to ma. So that means, or this equation shows that the force, the acceleration is directly proportional to your force. So how will we represent that the acceleration is inversely proportional to the mass? We can have it as A is equal to F over M. This equation means, or it shows that the acceleration is inversely proportional to the mass, okay, or to your mass. So of course, F represents as your resultant force measured in Newton, and your M refers to your mass measured in kilogram, and then your A represents your acceleration, which measures by meter per second squared. So that's it. That's the second law of motion. So let's have an example. Applying the second law of motion, let's have, I want you to try it on your seats. A block rather of mass 20 kilograms is pushed along a road with a force of 30 Newton. So now the frictional force is 10 Newton. So as you can see in the illustration, there is a frictional force which is 10 Newton, and then the block of mass with 20 kilograms is pushed along the road with a force of 30 Newton. So remember the direction of a movement. It is going to the right, and then going to the left is the movement of your, or the direction of your frictional force. So now the question is, what is the acceleration of the block? Do you have an idea? Okay, so I guess you have an idea. So let's now proceed to our solution. So we will use, or we will be applying the Newton's second law of motion, or its equation, which is F is equal to ma, where force is, or where acceleration is directly proportional to the direction of your force. So we have F is equal to ma. Next, we're looking for your acceleration in here. So your force, since since when you push your block of mass with 20 kilograms along a road with a force of 30 Newton, and there is, or considering the frictional force, which is 10 Newton, so to get your force, we are going to subtract the 30 Newton to 10 Newton since they are in an opposite direction to get your resultant force. So there is a resultant force in there based also in the previous law of motion. So 30 minus 10, that gives you 20 Newton, and that is the value of your F. The next, so we have M, your M now is equal to 20 kilograms. So that's in the given. 20 kilograms. So of course, next is you will, seems that, okay. A is equal to, since we're looking for your acceleration, therefore, we can say that your acceleration is inversely proportional to your mass. That gives you A is equal to F over M. So as you can see in here. So just substitute it. You have it, your F as 20 Newton. So 20, divide it by your mass, which is 20 kilograms also. And that gives us acceleration, which is 1 meter per second squared. So this is the answer. Your acceleration is now 1 meter per second squared. Okay, so as you can see, A is equal to 1 meter per second squared. So for a while, I just clear this one first. Okay, so next is, after the second law of motion, we will now talk about the Newton's third law of motion. So what is Newton's third law of motion, class? So it states again that to every action, there is an equal but opposite reaction. Again, Newton's third law of motion states that to every action, or in every action, there is always an equal but opposite reaction. So that is Newton's third law of motion. So example, if an object A exerts a force on object B, which is the action already, then object B will exert an equal but opposite force on object A, which is now our reaction. So in every action, there is always an equal but opposite reaction. So let's have an example. So firing gun, hammering a nail, book kept on a table, and launching rocket. So these are examples for Newton's third law. Sorry, these are the examples of Newton's third law of motion. Okay, so you can, or we can describe it in the illustration. So as you can see, the force of the hammer, or the force of the nail on the hammer, is going to the left. Kindly observe the arrow. So this is the force of the nail on the hammer. This one is the force, the direction of the force of the hammer on the nail. So as you can see, there is an opposite reaction, an equal and opposite reaction. Okay, so another example. Okay, so you can see there is an action, force on gas. And then the force on the rockets is the reaction. So the rocket and then the gas. So that is an example of Newton's third law of motion. That every action there is an equal but opposite reaction. So another example, force applied by book on the table, which is the action. And then the reaction is the support of the table. So another example, as I mentioned there a while ago, the example of what? Okay, firing gun. So that's the example, the last illustration. So now, so that is the examples of Newton's third law of motion. Okay, so now, after talking about the forces or the laws of Newton, or Newton's law of motion, we will now talk about the friction, something that will what? Resist with your force. So what is friction, class? What is the role of friction in motion? So friction is the force which opposes motion. We know that. So in short, stopping the force. So it always acts opposite to the direction of travel. And so you can see there, the friction in there, it will always act opposite to the direction of travel. So friction can be reduced by adding lubricants based on the example. So example, you can reduce the friction there on the illustration in here in the bicycle. You can reduce the friction if you lubricate moving parts with oil. So sliding surfaces must be smooth. If they are rough or rusty, there will be a lot of friction. So ball bearings reduce friction rather because they roll rather than slide. So that's an example of a friction or showing friction in our day-to-day basis. Okay, what is the cause of friction, class? Now, molecules in materials have a tendency to stick to each other when materials are pressed or rubbed together. Another thing also, nature of the surface, rough surfaces have more friction due to ups and downs which catch each other. So that's one of the causes of friction. Another example, I mean the illustration, the metal spikes on crampons dig into the ice. This makes a very big friction force. So you can see. So these are the causes of friction. Again, molecules in materials have a tendency to stick to each other when materials are pressed or rubbed together. Nature of the surface, rough surfaces have more friction due to ups and downs which catch each other. So these are the causes of friction. So what are the advantages of friction? So friction, class, helps us to walk. Imagine without friction. Try to imagine life without friction. It will be hard for us to walk. So friction helps us to hold the objects. Another thing also, friction helps us to stop a moving object. So these are the advantages of friction. Now let's proceed to the disadvantages of friction. So what are the disadvantages of friction? Machine parts rub together and become loose, and shoes and clothes wear and tear. What else? It heats up the moving parts and some energy is wasted in the form of heat. So these are the disadvantages of friction. So I guess we don't have much time. We will just end in here the disadvantages of friction. So now I will give you the time again to do the activity that I prepared for you for today. So if you have some clarification and some concerns, then you can just come over here. Do not be shy. I'll entertain your questions or concerns. So if you have some questions, okay? So thank you for listening, everyone. I hope you have learned something this afternoon, especially the law of motion or Newton's law of motion, and also for the dynamics. Okay, so that's it. So enjoy solving. So if you're done, you can just submit it right away to the class representative. So, okay, so that's it.